All right, just wanted to give you a quick lesson here in terms of solving systems of inequalities. We have talked a lot about systems of linear equations, which basically means there's an equal sign in there. When you graph them, it looks like two solid lines, and the answer is where the two lines intersect. Well, the minute we move over to inequalities, so let me just put one up here right now. So we're going to go y is less than or equal to 3, and then systems mean more than 1. So we have another one, let's say 1/2 x plus 1, and these can be found in your textbook. So there are my two there are my two inequalities that I'm going to put on a graph. And the difference between inequalities and linear equations is, again, you have with a linear equation, you have a solid number as an answer. There's a definitive x and a y coordinate where the lines cross. Well, inequalities are a little bit different. This one's pretty straightforward. Y is less than, I'll put them both in different colors. So this will be my red, and then this will be my blue. So y is less than 3. Quite simply, all you got to do is just go up. I know the y-intercept is at 3, so I'm going to put a dot on 3. Let me make my pen bigger a little bit. So I'm going to put a dot on 3. And then I'm going to use, there is no slope, so I am basically saying y is less than 3. The piece I've got to look at, there is no slope, or that is just solid, the y-intercept. So that's why I'm at 3. I've got a less than or equal to. So I've got to decide, is this going to be a straight line or a dotted line? And I look right at the inequality, and that tells me the answer. Anytime you have an inequality with an equal to, so this is less than or equal to, it's going to be a solid line. So I take a solid line, and I go straight across at y is less than 3, but the y-intercept is 3 itself. And I'm actually going to shade here. So talked about this real briefly in class. In order to figure out which side I've got to shade, so I'm either going to shade this side or this side, right? So I got to figure that out. Let me just undo both of those dots. Let me just erase those real quick. So what I do, how do I decide how to shade? Well, the bottom line is I pick a point anywhere on this side of the equation, and then I pick a point on this side of the equation. And I figure out whichever one is true. 9 times out of 10, the easiest point to pick is 0, 0, 0, 0, because it just simply works easy with algebra. So if I put in 0 for y, I get 0 is less than or equal to 3, and that's a true statement. So basically, this point 0 right here that I've got is on the true side of the line. So I'm basically going to shade underneath it. All of these numbers will make this statement true. Okay, so that's line 1. Switch pen colors. Now I've got 1/2 x plus 1. So there's my y-intercept. So I go to 1. There's 1. And I've got a legitimate slope over here. I've got to go positive up 1 over 2. Up 1, up 1 over 2. There's my next point. We'll put a couple of points. Up 1 over 2. There's my next point right there. And so I've got to decide here again, is this a solid line or a dotted line? I look, there is an equal sign right there. So there's my graph of the line right here, solid line, not a dotted line. And so I got to decide what this looks like. So now, a little different, I'm going to put in 0, 0, again, because 0, 0 is on the bottom side of this line. So I've got 0 less than or equal to 1/2 times 0 plus 1. So 0 less than or equal to 1, which again is a true statement. So now this one, I'm going to shade where 0, 0 is right here, so it's within the shading of what I'm doing. So that's all shaded. So in essence, the issue that I look at is, so I look at this and I say, okay, I just graphed two inequalities. What does it mean when there are two of them and there's a system of inequalities? As I look at my graph, I'll change colors one more time, and I look at it and I say, okay, so this must be where I shaded in twice. So in essence, here is where I shaded in twice, that chunk right there. And I can shade in black, and that, although it looks really messy, is my answer. Now I got to make sure I don't go above this, right? Because the y less than 3 line is right there. So there's my answer right there. Let's do another one, a little bit more technical. Color scheme. Here's my equation 1. Let's do this. Negative x minus y is less than or equal to 2, and y minus 2x is my other equation. Y minus 2x greater than 1. Let's pop up a graph here. There's my graph. I'll make it a little bit bigger. I'll have to cut into my equation. Here's my graph. Now the difference between this and the one I just did is I'm going to move things around in order to use slope-intercept form to graph these. So for this one, I am going to add x. For the red one, I'm going to add x to both sides. So I have negative y is less than or equal to x plus 2, which means y is going to be, I'm dividing by a negative number, which means I got to flip that sign. So it's going to be negative x minus 2. So there's my first equation I'm going to graph. Y is greater than negative x minus 2. So in red, I'm going to minus 2. There's my y-intercept. My slope tells me I'm going to go, this is a negative 1, so I'm going down 1 over 1, down 1 over 1, or I could go down 2 over 2. Down 2 over 2, up 2 over 2. So I'm looking at my inequality, trying to decide whether it's a dotted line or a solid. Once again, I've got the equals on the bottom, so it's a solid line. There's my line right there. Got to figure out which shade to graph, which side to graph. So I put in 0, 0. 0 greater than or equal to negative 0. It doesn't make much sense, but so I end up with 0 greater than or equal to negative 2. Is 0 greater than negative 2? It certainly is. So I'm going to shade the side that 0, 0 is on. Okay, so let's look at the blue equation. It's going to get messy, sorry. Y minus 2x greater than 1 if I add 2x to both sides. So I've got y greater than 2x plus 1. Let's graph that. I'm up at 1 on my y-intercept, and my slope is 2, so I'm going to go up 2, 1, 2 over 1, up 2 over 1. I'm going to go down 2 over 1, just so I get a good solid. The difference here is, boom, look at that, no equal sign at the bottom. So this is going to become, and I'll be looking for this, this becomes a dotted line. That's what my graph looks like. So 0, 0, I got to figure out, 0, 0 may or may not work for me, but as I look, 0, 0 is on this side of the graph. So let's plug it in. We're going to get 0 greater than, 0 plus 1, 0 greater than 1. That's not a true statement. So therefore, on this one, I am going to shade above the line. So I got two shadings. Going to change my color to black and see what's double shaded. So in essence, what I end up with is this piece double shaded. And there's my graph right there. That's the solution to the problem, the shaded region that I just circled in.